can look online. Let's see. Where's the? Gotta get the keyboard out. Hold on. Let me just see if I can look online. Whoa. This is put away kind of crazy, huh? I'm trying to get this mouse out. I need it for class anyway. So yeah. I mean, terrible to be the first person teaching in here. Let's see. Okay, let me see if we can go handicap. So we do maps. Search Lincoln Hall Theater. Whoops, this has to go the other way. Wait a minute. What? Oops, it's on caps lock. Okay. And so now we can look at the accessory. Don't they have a map?
That would be really helpful.
Building. What is it? I got an idea. I'll just go to, you know what I'll do? I'll just go to my website because I have, okay? So I'll go to, that's horrible. Okay, here's buildings. And campus map. So we're, Lincoln Hall Theater is right.
Probably right here. I think it's this one right there. Yeah.
Lincoln Hall.
Can you click it?
Campus.
This is ADA is accessibility maps. Is that what we're looking for?
Yeah. Lincoln Hall. Okay.
That was helpful.
Oh, it's that front row. It's that front door. Of course. Here, I'll show you. Come here. Yeah, it's just like right there, like that ramp. Just tell them to go. It's the Wright Street entrance.
Oh, okay.
The Wright Street front entrance. It's not the quad entrance. It's the other one. Is he here now, or?
I'll try to find him back upstairs, but I told him I would ask you if there was something you could do. But
Can I ask you a question? Yeah, can I ask you a question though?
Yeah, go ahead.
Here, I'm gonna turn off my mic.
That's fine.
What? I mean, like, what am I in here? What browser? I can't even tell.
You're using Internet Explorer.
Oh, no wonder. I hate it. Okay.
Yeah, there you go.
So I got to get out of this.
There you go.
All right, now it looks
Much better,
familiar.
right?
Oh, how did that happen?
Yeah. Looks like it defaults to Internet Explorer.
Oh,
Let me go try to find this guy.
yeah. How much time do we have?
So they enter into
You enter it through.
right here.
Yeah, they go like here. They just. Oh.
Okay.
And here, they're just entering through here, and there's the front door. Yeah, and see, they're coming in this way.
So they enter in from the right entrance, and then they can.
Central right. See, look, you could have asked them. Yeah, there are all these people who.
Yeah, thank you. Let's find him.
Maybe he's here already.
Thank you.
How'd you guys know how to enter? You've done it before? Did you entered through that? Okay. Hello, and welcome to Stat 100. My name is Ellen Fireman, and everyone here should get comfortable because we're going to go the whole time. The whole hour and 15 minutes or whatever it is, yeah. Maybe let out 5, yeah, oh, you're happy about it, good. We're gonna try to get, even though I know none of you have your notebooks, maybe you don't even know what a notebook is, but let me show you the way this course, maybe I should start by describing the somewhat unusual way that this course is taught through using not a textbook, but basically a workbook that will be available either later today or tomorrow at just one bookstore, TIS. That's the only place. And I will send you all an email when it's available. I have your emails. So, but tomorrow at the latest. So next class, you'll have it. Now come on in, Stat 100 people. This is your class, and sit down, get comfortable. So let me show you, maybe it's a good place to start by explaining how the class is conducted, and maybe that will may help you understand the course syllabus and the policies that I have, because they really stem a lot from the way that the course is taught. So let's go to this thing called the document camera here. And what this document camera is, it's just, it just shows not only documents, it shows people too. It shows objects. You see? You can see my hands, whatever. So last semester, here is what the notebook looked like. And this isn't the one that you want. You won't get credit for this one. You want, it's going to look like this, but it will be red. It'll have this cool picture on it. That's supposed to be me. An artist drew this, saying, isn't there, sort of a sweet resemblance there, saying statistics is never having to say that you're certain. Some of you who are my age probably understand, nobody's my age in here, so what am I even talking about? But maybe some of you have seen that movie Love Story. Have you ever seen that movie with Ali MacGraw and Ryan O'Neal years back? You did? I should probably show you a clip. It is so sappy. Anyway, there's a line from it that says, love is never having to say you're sorry. And they repeat this over and over again. So that's where that came from. It's true, statistics is never having to say that you're certain. We're going to look at probabilities, and we're not going to be certain about things. Now, so it's going to look like this. This is going to be the notebook, but it'll be red, and it'll be different, somewhat different. Let's check it out. It's a workbook that we fill in together. Like, we're going to start off talking about experiments. And there's lots of blank pages. That's my handwriting. And we're just going to work together so that hopefully it'll become yours too. You'll feel a sense of ownership. They're going to have examples from our class and from previous classes. And most important, we will have time, hopefully, to discuss things. You say, oh, how can you have a discussion in a class this size? It's rough, but it's so much better when people at least ask questions and somewhat have a discussion. We'll try it later today and see how it goes, okay? So just help me out. You can help me out right away by, if you ever have a question anytime during the lecture, just shoot your hand up. And if I don't, if I don't notice you, well, hopefully your neighbors will say, question, hey, question here, and get my attention. So we'll all help out with that. And so the idea is that class, if you come to class, I want to make it so that you won't have to do a lot of tedious stuff on the outside of class. If you come, people tell me all the time, if they come to class, fill out the notebook, if we fill it out together, some of it you do on your own with your neighbors, some of it you do with me, but we do it in real time. Unlike a PowerPoint, which you have to race to catch up and you're not sure how those steps worked. Or unlike the way I used to have to When I was a student, when I first started off, I mean, the professor wrote every single thing down on the board, and you laboriously, throughout the whole board, and you laboriously the whole time just copied everything he said. And you didn't have time to think. So this is a compromise. It's not like PowerPoint where it's just spoon-fed to you and you sort of feel like you're not even engaged. And it's almost too fast. And it's not like, just writing out the notes, which is, it's very hard to write and think at the same time. So this is a combination that's worked well. And most students love it. So I encourage everybody to buy the notebook and come to class and be serious about thinking about the problems while you're doing it. If you're serious about thinking about them while they're going on, ask questions, think, why is this happening, And some of them will be repeat examples and you'll do them on your own, or some of them there'll be some iClicker questions just to test to see if you knew what you just did. But if you do that, people tell me, well, I barely had to study. I did a practice exam or two and got an A. And that's absolutely true. Because there's a lot that can go on in class. But that depends on you taking the class seriously that way. Which means, and I know this is going to be difficult for you, which means not texting during it, not getting on Facebook and chit-chatting with your neighbor. I mean, it's worse than just destroying your own learning, which you're paying a huge amount for, way too much. It's criminal, I think, how much you have to pay. I really do. It's ridiculous. But you are paying that much. And I'm going to try, even in this setting, to make it worth your while. It makes the class itself worth something, worth a true learning. I feel like I owe that to people with all the money they're paying. And I'm getting paid too. So I hate this idea of just, students sitting in class, PowerPoint floating by, people texting, talking to each other. It's a colossal waste of everyone's time and money. And it's disrespectful to the learning process, the university, and most disrespectful to those students in here, and there's a whole lot of them, who don't do that, who really want to take it seriously. And I hear this every semester. I was trying really hard. I was sitting in the front row. I'd move away from these people. And it was just so frustrating. I know they weren't deliberately trying to ruin my education, but in effect they were, and I'm paying all this money. And and I know you're trying, but they're ruining it for all of us. So what I'm saying is this: there's no attendance per se points that you get for this class. We use iClickers, but you can get 100% without iClickers. And the reason for this is the iClickers are only to encourage you to come to class if you plan on taking it seriously. And then you will benefit. And you'll get a little benefit from the bonus points I give for the iClickers. But there is no attendance grade. The iClickers count 0 for attendance. In other words, you can get 100% in this class, theoretically, without attending a single class. It's probably been done. Some people can do that. And I don't mind. This is not high school. You're not legally obligated to be here. You're paying money to be here. And treat it that way. Treat it like, hey, this is worth it. And then don't come otherwise. Don't come just for iClicker points. That's the worst thing about iClickers that I hate. Because I don't use them for attendance and force people to come and all that stuff. But I hate that people feel like, oh, I have to come, and then they just play around, don't pay any attention, and ruin the atmosphere so that it makes it impossible for people to be serious here. And this course can be extraordinarily serious. I mean, it's simple, and I'm sure everybody who's come in here has heard SAIL 100, easy A, like probably on bathroom walls for an easy time, call, firemen, something like that, I would not be surprised if it's something like that. Oh yeah, easy A, there it is. All you have to do is blah, blah, blah. You don't even have to come to class. But I do try to make it simple. There's a reason people are saying that, but they also, if you talk to people and really talk to them, they learn a lot. It is simple if you come to, it's certainly simple if you come to class. And you end up learning a whole lot. And like anything simple, not anything simple, but lots of things, there's a deeper level. If it's important and simple, there's a much deeper level to it. And I try to be true to, unlike other statistics courses, instead of just sort of giving you the rules, I try to explore the deeper philosophical issues so that you'll understand the concepts behind the procedures and be able to actually use them in your real life, and more important, be able to have some power over the number gurus who always try to, it seems like they love their expertise and sometimes use it, like any type of power, to make you feel stupid, to enslave you. I mean, people always do this. When experts throughout the world, I don't care what they're in, people, once they have power, can abuse it. And that's certainly what's happening in today's society. Excuse me. That's probably my way of stopping myself from saying something too politically radical. My internal physiological mechanism. Ellen, shut up. But I believe this, and I think that we live in a time where we're giving power. Yeah, we're using all this technology, and there's an information age, and we're just like bombarded. It's basically running our lives. That's what's happening. It's running our lives. And we feel somewhat powerless in controlling that. We don't know how to make sense out of that information. We pick and choose the stuff that we already know to support what we already know, and just become more and more polarized. And worse yet, we feel on shaky ground. Cognitively speaking, I mean, educationally speaking, when people bring up p-values and what's statistically significant, this study proves that, and the other study proves something else, most people don't understand enough to evaluate that. So they just shut down and then feel powerless. Well, that's not good. I mean, that's my number one goal, is to give you some power in this society, as you should have as an educated citizen, and to not have that feeling, and to be able to understand the basics of like which studies you can trust, which ones you can't, what the basic methods are to evaluate data, what questions can be answered with statistically and what questions can't, what a p-value means, just so you'll be literate and you'll be able to use statistics in your life. Okay, so that's my wrap. So I said it all started with this book, and then I wandered into philosophy. But now let's look at the course policies, the syllabus, so you go to, there's a lot of different things here. There's this notebook that's not this one, but you have to get the red one tomorrow or later today. And then, let's say you're clueless, you forget everything about Stat 100. Where you go, you have so many courses, so many URLs. You're on a strange computer, or just, this is the way I always access all the information. I just go and Google. What do you think you would Google? If you're thinking about Stat 100, what would you Google? Stat 100. Try it. And there we are, the very first link anywhere that anyone has ever tried it. I've asked people. That's us. And turns out to be the syllabus. Sometimes it'll be directed towards the home page. It just depends on where people have been looking. So this is just basically some philosophy. But before we get into that, let's look at what you need to do, how this course is graded, and so forth. So the syllabus. And so you can access this anywhere, and there's so much information here. Now, unfortunately, all we have is this giant lecture, which isn't as bad. I mean, you don't have discussion sections. So what we do is we have a lot of these TA lab hours where these people give you individual attention to help you with your homework. So if you want to see when those are, they're here, and I'm in there too, I'm helping you. So it's 3 to 6 every day, and that formatting came out wrong, but it's in Illini Hall. You can check the map here, I hope. Yeah, Illini Hall, right through there. So, now, so you do get individual help. Now, it's not as good as sections. I mean, I think we might be one of the very few class, if not only class, of 1,100 people, or a huge class, that does not have any discussion sections. There's the other class I taught, what was it, linear algebra, Math 125, does that still exist? Yeah, that one didn't either. And both of them, because that one had a notebook that I developed, sort of made it possible to not have sections. So of course the university says, when you make something possible, oh, well, since you don't need it, things are going so well, we don't have to fund the sections anymore. You know, you do a good job teaching, and then they say, well, that'll limit, we don't have to have sections because they can learn it in a lecture because you have the notebook. Crazy. So anyway, but in statistics it's not so bad because these big numbers, 550 of you sitting here, 550 of you sitting in another section, and then 100 people sitting somewhere else that I don't teach, that adds up to 1,200 people in the class, make for a huge data set. So being a statistic in most classes is a disadvantage, you're just a number. Being a statistic in a statistics class can be turned into an advantage because I can make each one of you as a number come alive. How? By filling out, by basing the class on our own data. You can fill out anonymous surveys, we can do homework on that. We can do experiments on ourselves, we can poll ourselves. We have a big enough class where it's as big as most pre-election polls. So we can be our own scientists, and it makes it extremely exciting, and it makes us be able to explore statistics with data that we're totally familiar with, because that's ourselves. I call it statistics through narcissism. It is. I mean, it's wonderful, because this is the common thing that we have. I mean, some of you are interested in sports, but not everybody. Some of you are interested in financial stuff, not everybody. Some of you are interested in politics, not everybody. I mean, you could apply statistics to anything, but most of us are interested in ourselves. So it's the common ground we have, easy language. We can explore things like, you know, I don't know, when did you first kiss somebody? Or how many people in this world do you think you could truly love? Or how much money do you think would make yourselves really set for life? Or, I don't know, there's lots of different things we can, what's your favorite TV show? Anything. You can generate the questions, whatever you're interested in. We can collect data that no one else in the world has. We do have data that no one else in the world has. Absolutely we do. And we can just, like any scientist, they know their own data. That's how any field develops. So we can be immersed in data that we totally understand, and we don't have to learn all these languages, jump through all these hoops. How is the data collected, you know? What are the measurements it's being measured in? How reliable, blah, 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 blah. Because we know it, it's us. All right, now, that's why so let's move on. And so here, let's go. Okay, so here's the syllabus, because I'll jump around too much. So you can go to those lab hours, and this is the only thing that you need to buy, and I apologize that it's gone up in price to $35, but it really is the only thing you have to buy for the course. What about an iClicker? How many of you already have an iClicker? Well, you don't have to buy one then. How many don't have an iClicker? If you don't, you can buy the cheapest one if you can find it, because we're only using the iClicker once, but if you need the 2s for another course, that's okay. I mean, 2s and 1s, it doesn't matter which one you have in this class. So try to find the cheapest one you can unless you need it for another class. Okay, so I don't feel so bad. So then it's $35 for the course. You don't really need to buy a special calculator. How many of you have some kind of calculator? Okay, if you don't, you can buy a cheap one. Unless you like those graphing calculators, you can buy one of those. This recommended text is nice, but you don't need it, and we can provide it to you. So that's how much this course is going to cost. Now, there's homework. There's a lot of homework for this class. Because in keeping with wanting you to really understand what's going on in lecture, I have homework twice a week, so that Monday night and Wednesday night. So that when you come here, you already understand something. So otherwise, if I don't do that, people, when they come to lecture, they're like, half of it goes over their head. But if you've just done the homework on Monday night, Tuesday you come to lecture. So let's check out the homework site. And the homework is done where? It's done on Lon Kappa. How many people have used Lon Kappa before? Honestly, how many people don't like Lon Kappa? I don't either. But from your point of view, I'm going to try to make it nice. From my point of view, it's a nightmare. But from yours, I think, how many do like Lon Kappa? I think that a lot of you are going to like it in this class, because I'm going to try to make it user-friendly. So let's just see what it looks like. Everybody now is registered, so you can log on, and you should try to do that today. And you just put in your user ID, and the password, I don't know which, it's your ad password, I think, or the same one you use to register, I think. All right. And then, it doesn't look like this for you, I promise. Okay, here we are. Let's see what it looks like. Let's switch to a student role so you see what it looks like from your point of view. What? Wait a minute. Okay, so far what you have is you have Monday homework due every Monday. Starting this Monday, Wednesday, homework due every Wednesday, and you have these bonus surveys where we collect our own data. So what's the first thing that's due? This Friday, you have something due. Okay, so you should go on here, and here, this is what it will look like. You could do the bonus survey. And this is where we collect a lot of our data, and you get bonus points for doing it. It's absolutely anonymous. That's one capability that Lon Kappa has that's quite unique, is that it will give you credit for doing the survey, and there's no way in the world it knows who submitted what answers. So we really have more of a potential for getting honest answers. It's truly anonymous. I'll get fired if it's not. I promise you I would. This survey are completely anonymous. You receive the full 5 points bonus credit if you answer all the questions. Okay? So you just answer them. They're short. They take 2 minutes. And then we can analyze the data. We can look at it. So if you have any questions, this is just the first one I thought. So I'm going to read this because it's important. And I want everybody, please answer honestly. The truth is really more interesting and often stranger than lies. You'll see that. You'll see what strange things happen. What it means to be way out on the tail of a distribution. Plus, this is our data. We are the ones who'll be analyzing it. So if you lie or just joke around, you're just messing up our own data. So that's annoying for everyone, very time consuming for me because I have to go through it and trash those. So for example, I could just do this, you just answer. Well, but you see, you're going to be, whoa, that's not right. See, that's what happens. And then you have to say, is it a lie or is it just a mistake? Like, I didn't deliberately do that, So you just have to go through and, try to, like if I did something like this just by accident, that couldn't, unless that was just very strange. It's about there, I think. So you just go through, and no one's going to be seeing your answers. So whoops, that's not right. So you don't have to see these. I don't have to go on, but you have to answer every single one of these, every single one, and then you submit it, okay? You just answer every one, you submit, you're done, you've received credit, and you get bonus points for that. 25 total. There's 100 altogether, 50 for the notebook, 25 for that. So any questions about that? Now, what does the actual homework look like? So let's go back to the, I always go to course contents. I don't know where you guys start, but I think that's helpful. And what you're going to see on your course contents is like Monday homework and Wednesday homework. So that's already posted too. So you can look at these. I don't know, this is a kind of funny one. These are real studies. We're starting off with experimental design. So you're going to have to read some studies and then answer some questions about them. Okay? So this is one where people were given a lip reading task, and they were told that either a male was observing them lip reading or a female was. And it was decided randomly. But otherwise, you know, they knew somebody was out there, but they didn't see the male or female. And then it's kind of interesting. Men who thought they were observed by a female had worse scores. And men who thought they were being observed by a male had about the same scores. If you want to read the study, it's here. I usually give links to the study. I love that picture. It's so classic. You know, like sort of very lowbrow. But lots of studies are lowbrow like this. They look lowbrow, but they might be very, very decent studies. And other ones that look really fancy are in, you know, some Journal of American Medical. I just read one in Harvard magazine. It was just terrible. So you just look at the, you know, you don't necessarily know by those pictures. You have to read whether it's a good study or not. How do you know? Well, that's going to be what we're going to do this lecture. But before I do this, we have to, first of all, I'm running behind. What time is it actually? Oh my goodness. Okay, we're going to speed this up. So what else do we need to do here? Where do you find out? So that's the Lon Kappa side. Anything you turn in is turned in on Lon Kappa, and the very worst thing about Lon Kappa that I hate and everyone hates is there's no penalty for turning anything in late. What it means is you just get a 0. You can't, I've argued with them, they won't do any kind of late homework. So they say it's because the answers show up right away. I don't know, they don't do it. So you can read all the homework policies, and I have an incredibly liberal homework policy. I try to make the policies take care of these things. So you get to drop, I give you extra, you can read it, but I think you'll be happy with the policy. I don't want to waste time, but you can go through it and you can read this. All right, now what else? Exams are really important, and here's when they are. There's 3 evening exams, and they're worth 20%, 20%, 20%, 60% of your grade, and then a final is another 25% of your grade. So 85% of your grade is on exams, and 15% is on homework. It's pretty high, but I really prepare you well for the exams, and if you come to lecture and the homework, everything's written by, it's all integrated. So the homework will prepare you for the exams, the lecture, everything. So you have your final then, May 7th. That's a F1 section, okay. And here's tons of practice exams from previous semesters. For each one of those, you get practice exams and keys, and last semester's will be in your notebook. Study guides and last semester's exact exams will be in your notebook. Okay, no makeup exams. Instead, I count your final. So many policies to review. So that's grading, calendar. So you go to the calendar. Here we are. Hopefully, we're going to start with chapter 1 and get something done there. We're doing an intro. Here's where our first bonus is due, and here's where all your homework is due. Here's the whole course schedule. All right. What else? Questions. You got to have a question so far. Anybody? Anything? Okay. So that's the calendar. Why do I give night exams? Do you want to know the reasoning behind any of this? It's just to give you more time so that people, you're not all crowded in here. Just people get anxious on math exams, and I just want to remove that element. No one is ever rushed for time. You sit every other seat. I try to make it, if you're not rushing to the next class, it just seems like it reduces the anxiety. And you can take a conflict exam, anybody who wants to, you can take a conflict exam the day before, not the day before, right here, 4:30 to 6. You just sign up on Lon Kappa, no questions asked. If you just don't like to take an exam at night, when it's dark out. All right, now, exams, homework. All right, this bonus formula I use is kind of complicated. You can read it basically. I don't really want to waste time on it. Basically, you get, let's say, here's a good example. Let's say you got a 75%, without any bonus points, 75%. That's your average, 3 exams, your final, and your homework. Now, let's say you did every bonus point. You had 100 bonus points. How would that help you? Basically, what you do is you take that 75%, you change it into 75. Maybe is there a better place to look at this? Hold on. Yeah, so you would rewrite 75, let's say it was 75%. So you would write 75% as 75 over 100. And then you divide your bonus points by 4, that's 25. And then you add 25 to both the numerator and the denominator. So here you'd add 75 over 100, and so you get 100 on the top and 125 on the bottom. So you'd go up 5 percentage points. And you can just figure it out depending. It helps you more the worse you do. The worse you do on the required work. You can see that, because what if you had 100%? What if you had 100% on here? If you had 100% here, think about it. You'd have 100 over 100. So when you add 25 to the numerator and the denominator, you'd still just get 100. So it caps off at 100. You can't go over 100. And the lower it's to help those who need it most. All right. So when are we going to start? Here, this will answer all your clicker questions, and if these don't, you go here. Now, let's say this is really important, so I want to go back here. If you have any questions, that's where you should ask them. Okay? And we'll answer them the same day. Don't personally email me, because it just gets, my Illinois account, it just has too much stuff and I lose things. So just email there. Everything gets answered by the Stat 100 team, me or someone else. All right. So, are we done with this syllabus? Oh yeah, almost. I said you get bonus points for filling out the notebook. Maybe I didn't, but here's how the extra credit figures in. So if you do complete well, what if you miss a lecture? Well, you can go to lectures, or if you just want to look at a lecture again because your handwriting's terrible, you go to lectures and you can click on, and these are all the filled in lectures. But we haven't done anything yet, so it's not up there. But it will be as soon as we do a lecture. Okay. So those will be filled in on Friday. And the last thing besides this, which I'm not going to explain today, this is Compass. And that's where you see all your grades, Compass, and because Lon Kappa has a lousy grade book, so you don't do anything on Compass except register your iClicker and look at your grades. We post all your grades there. Lon Kappa's too, so ignore your grades on Lon Kappa, whatever happens. The grades you get on Compass at the end of the week will be updated. Your iClicker scores will be updated. Your homework will be there. It's your job to review it all. especially with those iClickers. I get a zillion, every semester I get about 50 people who've done all the iClicker work, and I can't give them credit because they never registered their iClicker or registered a wrong iClicker or something. So be sure you're getting credit. Literally, I have about 50 people who got who just don't get any, because they never registered it and they never checked. So be sure, like a bank account, check it. All right, so I think that's pretty much it, and, tired. So you asked me a question now, because I want to relax before we start the lecture. Ask me something, or... Where did I go to college? Oh, this will probably surprise you. I went to Harvard. I don't seem that smart, huh? People always get surprised. I feel like, what? I don't look like a, people always... Actually, I'm kind of proud, because probably you have this image of it as being a really snobby place, which it can be. And hopefully, when people get surprised, it means that I'm not coming across as a snob. At least I'll take it that way. And the big lectures were completely different. For one thing, we smoked during them. I smoked. The professor smoked. We all smoked. I am not kidding. I mean, not everybody in the class smoked, but I had a little ashtray, a green plaid ashtray. There was a bean bag on the bottom. Picture this. You know what a bean bag is? Yeah, like you throw, well, I didn't throw it at things, but it was a hefty bean bag, and then it had a little silver, very lightweight metal top that was shaped, like an ashtray on top of it. The point being that if you could place it on the seat of the person ahead of you. It would mold around the seat, so that person would have an ashtray right at their back where your cigarette would be hanging. I mean, I'm surprised nobody's hair caught on fire. And the professors all smoked. Well, I was in philosophy at first. Philosophers, big smokers. And that's why I started to imitate my professors. I thought my professor was I was completely a non-smoker. Requested a non-smoking roommate. Thought smoke was disgusting, and then fell in love with two of my philosophy professors who were chain smokers. 10 in 1 hour. Imagine that. I mean, it was 9 until the end of the semester. He broke his record. I was keeping track, statistics person for the class, and I said, yes! And we all cheered. He did 10. It was such a feat. I mean, we didn't think it was possible. I haven't smoked for years. And I hope none of you do. It's the hardest habit to ever break. Awful. Any other questions, comments, remarks? All right, so I still didn't tell you, how much time do we have? 11:40. In this class, it's not an hour-long class. Wouldn't that be nice? Wouldn't that be nice? But we'll never get through it if it's an hour-long course. But that's why we have to take a break. We have to have some humor. And people say I tell too many stories, I go on too many tangents. But the reason I do it, really, besides just liking to do it, I wouldn't if I didn't think it was pedagogically valuable. But I read these amazing studies that I'll tell you about in more detail, but they basically say that if you give people a break, any kind of break, just completely, it doesn't have to do with statistics at all or what you're teaching. In fact, it's much better if it doesn't have a thing to do with what you're teaching. That somehow when they come back, they're able to learn not only the new stuff better after the break, but they can retain the old stuff. And even with really lame commercial breaks, it's been shown over and over and over and again. It's almost like we need a break in order to focus again. And if you just have a so I deliberately do it, like I'm doing right now. But it's also, I hope it can be fun. I hope I'm not the only one who has to do it. I hope you can have a story or two to tell and perform, do something, come in and just break it up, because it will help everyone. It is not a waste of time. And people say, oh, just let us out early. But it doesn't serve the same function. You learn better with the break. And I'll direct you to the studies. We can analyze that study, see if it was well done. So, speaking of studies, so let's have our first lecture, because we don't have the book. So I start off, overview of the class, start off talking about design of experiments. How do you design an experiment so that you can trust the conclusions? You usually design an experiment to find out if something works or not. Does the drug work or not? Does some educational method work? Does some advertising campaign work or not? You want to know whether it works or not. But if your design is flawed from the get-go, you're going to spend all this time and energy, get all this data, and you'll analyze it, because everybody does. They stick all this data into some software program and just comes up with a p-value and everything else. But it's meaningless. It has nothing to do. It does not tell you at all whether what you're trying to find out. And it can be very dangerous. Very often you'll see examples where when the study was done wrong, they concluded that drugs worked that turned out to be terribly dangerous. One that I'm thinking of in particular is the thalidomide drug, where pregnant women, they thought it was going to help them, and their babies were born with very, very shortened limbs, like flippers, all of them. And this was just about, if they took this drug, that's what happened. Oh, and they could have known. Those studies were so flawed. Everybody in Stat 100 would know they were wrong. So it's very serious. You have to have a good experimental design. Otherwise, you cannot trust your results. And what is a good experimental design? And what do you do if you can't get a good? How can you save a poor experimental design? So that's the first place to start, the very first place. Okay, so then what do we do? After we start that, so we understand sort of where the interest, one of the amazing things the statistics can do, then we're going to have to backtrack and learn some statistics. And we're going to just have to learn how to do what's called descriptive statistics, which is just describing masses of data with summary statistics and summary graphs. You probably are already familiar with these. A summary statistic would be an average, or a median, or a mode, or a standard deviation, just a single number describing. Like when all our data comes in, and I asked you how many pets did you own? It's going to be like 1,200 answers, 1,100 answers. And one summary statistic could be the average of everybody's answers. That would be a summary. Okay, now another important descriptive statistic will be a graph. So instead of seeing like just a list of all these numbers, for like in our data, 1,100 numbers, ranging in pets, maybe from 0 pets up to 100. Some people had 100 pets on a farm or whatever. And just instead of making some sense out of it with like something like a bar graph called a histogram. We're going to look at that. And there are a number of different graphs we can use, but the histogram is the one we're going to focus on. And then we're going to look at bivariate data when you have two variables, how you could describe the relationship between them. Like, like height and weight. The taller you are, the more you weigh. It has a positive relationship, and we can just graph that with a simple scatter plot. And we'll do calculation. The summary statistic there would be the correlation coefficient. And we can, so that's what we're going to do next. And then we're going to get into the more interesting part of statistics, which is making predictions. Not just descriptive statistics, describing what you see in front of you, but what's called inferential statistics. Making predictions about the future based on limited data, or on a population based on a limited sample, make predictions about whether you're going to win or lose in gambling games, etc. And to do that, we need to know a little bit, how do you make a prediction? You have to have some insight about what the probabilities are. So we have to do just a little bit of probability, just enough so that we can do this predictive statistics. So unlike most people, in intro stats, I don't spend a whole lot of time on probability for probability's sake. I just give you enough so that you can do this predictive statistics. And then the inferential statistics, and then we're going to start like doing inferential statistics, looking at pre-election polls. For example, looking at how small samples, the size of less than our class, can successfully, like in the last election, successfully predict how all 200 million Americans who voted, I guess, about that, maybe 150 some million, what actually happened. And you see that we were able to do that based only on sample sizes less, many of them less than the size of our class. Sort of astounding, we'll understand that. And then finally, we're going to look at what's called significance tests that are going to take us all the way back to design of experiment. Okay, so you design an experiment, all right, to see if some drug works. And you always have to have a comparison group. So a certain group takes the drug, and a certain group doesn't take the drug. And then you'll compare their cure rates, or so, whatever measure you're comparing. And let's say the group that took the drug actually did better. All right? Do you know the experiment worked? Well, not if they just did a smidgen better. You know, how much better? That could just be chance variation. We could just have accidentally assigned sort of healthy people. They're not the same group of people. They're not identical in every way as much as we'd like to match those groups up. It could just be accidental differences that, you know, that group just happened to be unlucky, or lucky, the group that took the drug, and actually had a little bit of a higher cure rate. That's not, we wouldn't think that if everybody's cured who took the drug and everybody died who didn't. Obviously, we wouldn't need statistics to tell us the drug worked. But often it's in between. So the question is, how big a difference do you have to see? How big a difference do you have to see before you can say, hey, I think the drug worked? At what point can you do that? And it's a very interesting question, both philosophically and mathematically. So we'll explore that, and that's basically what the p-value is all about. That's the chance that you would see a difference as large as that if the hypothesis you start off with, like let's say the hypothesis was that the drug really worked, or that the drug didn't work, and it was just chance that the drug didn't work. It's the likelihood that you would see that just by the luck of the draw. So we'll get into that later. But so that's pretty much the course in a nutshell. And now we have just enough time to actually think about how to design an ideal experiment. How to design an ideal experiment. So let's pretend, I want you guys talking. So let's see if we can get a discussion going. So let's pretend, plus I don't have a notebook. This is the only tool I have now is you thinking about it. All right. Let's say we had the power to design some important experiment. And the experiment was to test the effectiveness of a drug that is designed to improve quantitative thinking. So to help you do better in statistics. All right? And it's already been proved safe in the laboratory. Maybe they gave it, they have these different stages of clinical trials, and it's already passed that one. And it's now time to test it in the real world. So it's called a field trial, clinical field trial. And we volunteered, because we have 1,200 people, to test it in our class. So there's a number of options that we can do. Maybe I should go back to the document camera and write down some of these options that we could do. And so we can think about them. Okay, so one option would be what? We could Let me think about what I wanted to say here, sorry. Well, how about this? How about I just give the drug to everybody in Stat 100 this semester, my 2 sections and the TA's 2 sections, that's 1,200 people. And then compare you guys to who? To my class last semester. First of all, what would I compare? How about your overall scores at the end of the semester? How's that? And so I'd give you guys the drug. They didn't have the drug. That's one option. We could do that. All right, I was thinking about these options before, and I wrote them down to the TA, so we can just post those up here. Let me see if I have something to scroll down with. Okay, this was just directions. Thought I was just going to talk it out, but I don't feel like writing right now. So, give all 1,200 students the drug and compare the overall average to previous semesters. That could be one design. Another one is give the drug to those who want it and compare it to those people who don't. You can't force, actually, I can't give you all the drug, that's illegal. I'd have to ask for volunteers. How many of you would take such a drug? Raise your hands high, I want to see if I'd have enough. That's all? It's safe, it's going to help you do better in statistics. You don't even want to try recreationally? No, I'm teasing. I don't want to advocate drugs. Let's see, raise your hands high. How many would take it? Okay, how many wouldn't? How many aren't sure and have to think about it? Okay, so, good plan. This is what we could do. We could give it to those who want it, and then compare their scores to those who don't want it. Then everybody would be happy, right? It would be the same semester. That might be a good plan. Maybe we should stop right there and think about that. Do you think that's the best plan? Should I give you more options? Do you want more options to think about first? Okay. What else did I write down here? All right. Have us instructors, there's me and the 2 TAs, together with the researchers who have knowledge on exactly who this drug helps and who it doesn't, decide in the best interest of the students who would benefit the most from the drug and who wouldn't. And in consultation with doctors, the way any medicine's prescribed, and then make assignments to treatment and control that way in the best interest of you guys, but us deciding who we thought would be most helped by this drug and clearing you that you wouldn't be harmed by it. It's another option. Now remember what our goal is. We don't know if this drug works yet. This might be we haven't decided whether it works. What we're trying to figure out is, does the drug work? Would this be the best way to decide? Another way would be to have the instructors, or maybe somebody even more objective, who wasn't involved, deliberately try to match people up. Remember, our goal is to make the 2 groups alike as possible. If you're all twins, it would have been ideal. I could have split you twins in half, give one the drug, the other half not. But you're not, so I have to, matching you up, because I don't want to put all the A students in one. I want to think of all the relevant characteristics that could possibly affect your statistical, your success in this class. I mean, your high school background, what courses you've taken, your ACT score, everything. What your course load is and other courses, your major, and match you up. And then the other last one is just I'm just going to leave this up to chance, to just randomly assign people. Flip a coin. Heads, you go one way, tails, you go the other. That's it. So those are all you want to vote on them? You want to argue for them first? Okay, anybody have a strong feeling? We're supposed to decide. Anybody have a strong feeling of which way to go? In the back, did you have your hand raised or are you just scratching your head? Oh, come on, somebody must have some preference here. Yeah, go ahead. Randomly assigned. Okay, how many people want to agree with him? Woo! Okay, you got a big support group there. Who wants to? Do you want to argue the case? Brought it up. You want to argue it, or somebody else who raised their hand want to argue why randomization is best? What did he say? More fun. Okay. More fun for who? Oh, just like a lottery. Okay. What were you going to say?
Eliminate bias.
Eliminate bias. Because an objective procedure is deciding and not a human being. Eliminate bias. Let's think about that. Well, for other important decisions in your life, like who you're going to fall in love with, what your major is, you don't just let random choice decide, do you? I mean, to eliminate bias? Why do we want to eliminate? Okay, let's think about it. How's it going to eliminate bias? Why is it going to? It's an interesting question. Eliminate bias. What if we only had a few people, like 20 people, and I just flipped a coin, or I put the 20 names in a hat and pulled 10 of them out and said, okay, you guys are going to get the drug. Your remaining 10 are going to get what? What should they get? Nothing? A placebo, you know too much. A placebo. And I shouldn't be the one doing this. I don't know who's in which group because we want to eliminate all bias. You've learned too much already. This isn't as much fun as it used to be. All right. So, but it's still, I want you to think about this. So you want the two groups to be as alike as possible. And you think that if you do this randomization, but what happens if those 10 people that you pulled out tend to be many more A students, and you have you have 3 F students in the other group, or low ACT scores. Do you still think randomization is good? I mean, randomization can lead to big accidental differences. Don't you want to eliminate that possibility? What? Can you think of a way? Isn't there a problem with just randomizing? Would you really do that? Would you really do that? Let's say you did that, and all the women end up in one group. And the guys it's just not an even thing. You feel like you could have done a much better job. Would you just go ahead with the experiment? No, you would adjust it when? Do you know what you would do? I think your idea of randomization is right on. Right, absolutely important. Absolutely. But all I'm saying is that you'll need a very big sample size before those accidental differences that you're going to see with randomization are going to average out. If you flipped a coin 1,000,000 times, yeah, you could expect to get pretty close to 50% heads and 50% tails as long as it was a fair coin. But if you flip it 10 times, if you have a small sample, you could easily get big differences. You could easily get 70% heads and 30% tails. So all I'm saying is think about what you're doing. What you want is randomization. You're absolutely right. But if you have a small sample, or really any time, ideally the best thing to do would be use a combination. Would be to first match everybody up as best you can. It's very time consuming and it's sort of unnecessary if you have a huge sample. But if you don't have a huge sample, you take 2 people, match them up. Let's say these 2 they have the same hair color pretty much, well, not really, but they're both in the front row. Maybe I think these 2 both were in similar, oh gosh, yes. So these 2 look like they're kind of matched, and pretend it was matched on paper with their scores. I'm not talking about their looks, I'm just making a joke. So what I would do then is at the decision time, it's fine for me to match them up. But then at the decision time, I would flip a coin and decide or they'd flip a coin. I'd have them do it. And we'd say, heads, they go into treatment group, and tails, they go the other way. Doesn't that combine the best? As long as the final decision of which group they go in is completely a non-human, unbiased, objective chance procedure, then we've eliminated bias. We've not only eliminated bias, we've what's called stratified more, did everything possible to make those two groups alike. So yes, randomization is important, but don't idealize it. Understand, at the final decision, you have to use it. But ahead of time, you can do other things. But I want you, other thing about randomization that nobody mentioned, I just want to do an experiment on this and see what we mean by randomization and see another problem with it. So what I'm going to do is I want you to all participate in this experiment. And when this will be the last thing we do today, and it will only take a few minutes, less than a few minutes. Less than a few minutes. Okay, I'm going to mute this for just a second. All right, and what I'm going to do is on the screen up there, you are going to see a set of numbers. And as soon as you see them, I want you to randomly decide to pick one. Just pick one randomly, just before it enters just your brain. Just pick, you'll just see it for a minute. And then keep the number to yourself. Can everybody do that? Okay. So here are the numbers. Here are the numbers right now. And you'll just see them for a minute. Oh, you've already seen them for a minute. Oh, darn. Okay, did everybody pick a number? I should have just shown them for you for a second. Okay, so now, everybody knows their numbers, so let's see. How many here picked the number 1? Raise your hand. How many? Come on, everybody has to raise their hand. Let's all participate in this. If you picked the number 1, raise your hand. What's happening? 1, 2, 3, 4, 5, 6, 7, 8. How about if you pick the number 3? Raise your hand. Okay, this is the experiment. This illustrates why it illustrates two things. One, the difference between what we mean statistically by random and what we mean in everyday language by haphazard. But more importantly, it illustrates the hidden biases we all share. And whoever said that randomization was key to eliminate these biases, it's not only the biases that we're conscious of, it's the very fact that we are hardwired to be subjective. We evolved to be this way, and we have biases we're not even aware of. How many of you knew you were anti-1? So the other thing is, it illustrates, so what if I really wanted, the way we're going to use randomness in our class mathematically. Hold on, do you want one? Do I have time? Yeah, oh, aren't you guys leaving early? This class gets out at what time? What? So you still have a few minutes. So why do people behave that way? On the first day of class, don't. All right, this is an important point. Okay, it also illustrates the difference between what we mean mathematically by randomness and how we use it in everyday language. I said randomly pick a number. That meant like haphazardly. When we talk about randomly picking a number, I wouldn't ask you to do it by just haphazardly choosing one. What would I do? I would have, what I mean by it in this context would be to have each number be equally likely to be chosen. So instead of having people just randomly pick a number, how could we model that? How could we have each number be equally likely to be chosen? Can anybody think of a way? Yeah?
clickers, and then whenever like a certain number of like people select a certain number, the number disappears.
Whenever people,
Whenever like a certain amount of people like pick a certain number, the number will then disappear.
but that's still not the same thing. That's preventing some people from voting the way they want to. It's sort of, you know, after the fact, eliminating their preferences. I don't want their preferences to come up at all. You know what I mean? Like, how would we just eliminate their preferences and have you just act as objective machines, basically, not as people?
Drop from hat, like everyone has their own.
Absolutely. Like, everybody could be given a hat with 4 tickets in it. And you'd shake it up, and then you picked a number, right? And then you told what your number was. Do you think we'd see anything like that distribution? Because of your belief in this objective random procedure, don't you think that you would get close to pretty much even distribution that way? So that's what we mean by a random procedure. An objective chance procedure, where in this case, each number would have the same chance of being chosen. That's what we mean when we want to pick potential in nationwide elections. We want each voter to have the same chance of being chosen. All right, great lecture. Thank you.